We will continue with our section 6.5. This time we're going to talk about a concept called percent yield. A yield is a product, and in order to calculate percent yield, we need to look at the ratio of an actual yield to the theoretical yield of a substance. The actual yield, which we will symbolize as A in the equation, is the actual amount of product that is being produced in the laboratory. The theoretical yield, which we will symbolize as T, is the amount of product we should produce in lab if nothing goes wrong. And in order to calculate theoretical yield, we're going to use the balanced chemical equation. At the top of the page, you can see the percent yield calculation. This is not on your reference sheet, so it's an equation that you must memorize. And you can see it's simply just A over T times 100. So let's go ahead and try one of these problems out so that you can understand how they work. Everything that we learned in the last section will be applied in this section. So let's go ahead and take a look at a problem. If 4.20 moles of hydrogen react completely with oxygen, how many grams of water are produced? So you can see that your unknown is grams of water and your known is 4.2 moles of hydrogen. As stated earlier, I'm going to do a road map, moles of hydrogen to grams of H2O. And we'll go ahead and do this problem. We'll start off with 4.20 moles of hydrogen. We're going to do our T-chart. We're going to get rid of moles of hydrogen. Because I'm in moles, I can use the balanced chemical equation to switch from any substance to another. And so obviously I want water, so I'm going to do a quick switch to water. I'm going to grab the coefficients from the balanced chemical equation. There's 2 water molecules, you can see that there, for every 2 hydrogen molecules. And then I'm going to go one step further, and I'm going to get rid of moles of H2O, and I'm going to go to grams of H2O. Remember that moles and grams are related through the molar mass conversion factor, which says that 1 mole of a substance is equivalent to the molar mass of that substance. Water's molar mass is 18.02 grams. We're going to cross out our units that are the same through the equation, and we'll do the math. Keep in mind that's going to cancel out, so we're really just multiplying 4.2 times 18.02, and that's going to give us 75.7 grams of water. So this is very similar to a mole mass problem that we did in the last section. What I need you to understand now is that amount that you just calculated, the amount of product produced, is actually the theoretical yield of water. Using the balanced chemical equation, this is how much water should be produced if you follow the recipe. 2 parts hydrogen for every 1 part oxygen. You should get 2 parts water. And starting off with 4.2 moles of hydrogen, you should get 75.7 grams of H2O, as long as nothing goes wrong. So it's important to understand that all those calculations that you just did in the last section, when you have calculated an amount of product, that was a theoretical yield that you were calculating. You just didn't know it at that time. So let's take this problem one step further. If I asked you now, what is the percent yield? If only 60 grams of water were actually produced in lab, you now can figure out what your percent yield would be. And so, of course, we're going to use the equation A over T times 100. Your actual yield was given to you in the problem. So we're going to put that on the top. Our theoretical yield was just calculated. It was 75.7 grams. We're going to put that at the bottom. And we're going to divide the 2 and multiply by 100, making sure that we give our answer in proper number of sig figs, which is 3. We get 79.3% yield. You can never have more than 100% yield. So be very careful with that. That would be a clue that you've done something wrong in your calculation. And if you think about 79%, look at that in terms of a grade. It's not great. We want to get as close to 100 as possible in terms of our yield. And this is a really important concept in industry because there's lots of companies that have hired chemists to produce their product and they want 100% yield. Sometimes that's not going to be possible because there's side reactions going on, but a lot of times that chemist can perfect that reaction to get the most yield for the buck of the company. All right, let's take a look at another problem. You've precipitated 8.5 grams of barium hydroxide. If you start with 4.57 grams of sodium hydroxide, what is the percent yield? So the first thing I need you guys to understand is there was an amount given to you in this problem. This was not broken down like the first problem we did. Notice that sodium hydroxide is a reactant, and the 8.5 grams of barium hydroxide is a product. Remember what the word yield means. It means product. So this 8.5 grams is the actual yield of the problem, not the 4.57 grams of sodium hydroxide. That is a reactant. And so that is what we would start the problem off with, because we're going to convert from grams of NaOH, which is a reactant, and then we'll take it to the grams of the product, the yield, which in this case was the barium hydroxide. So this is a mass-mass calculation. It's going to be really important for you once again to remember that when two amounts are given to you in the problem, this is the first time you've seen a problem like this, one will be a reactant amount, one will be a product amount. The product amount is going to be the actual yield. The reactant amount is the starting point in order to calculate the theoretical yield. So if you look at the equation below, you'll see that I'm converting my grams of sodium hydroxide to moles of sodium hydroxide, and I used molar mass. 1 mole equals 40 grams of sodium hydroxide. I'm then getting rid of moles of sodium hydroxide and going to moles of barium hydroxide. That is my mole ratio, and I take these numbers from the balanced chemical equation, and then you can see once again I'm converting from moles of barium hydroxide back to grams, once again using molar mass. I need to be in grams because I have to use the ratio actual over theoretical times 100 to get the percent yield. So when I do the calculation and I cross out everything that is the same and I multiply everything across the top, everything across on the bottom, and divide the bottom and the top, I get 9.79 grams of barium hydroxide. That is my theoretical yield. So remember, your actual yield was 8.50 grams. Your theoretical yield is 9.79 grams. And when you put that into the calculator, you'll end up getting 86.8% yield. And that's a little bit better. Think about that in terms of a grade, 87%. So not so bad there. So this concludes our very short section on percent yield. Hopefully you'll do some more practice in class and at home and get this skill under your belt. See you then.